like to welcome you all to this Google Maps platform talk. We're going to take a deep dive into building for performance and scale. So I'm Travis McPhail. I'm one of the engineering leads for the Maps platform. Just to give you a little context about who I am. Since I've been at Google, I've worked on a number of different products that you are probably familiar with, from Maps to Earth to Street View. But even before then, I worked in various industries, from the special effects industry. I worked in gaming, biomedical, seismic data analysis in oil and gas, and more. So in short, I'm a graphics geek. But more important than that, I have a passion to help people fulfill their purpose. In the context of today, that is to help each and every one of you incorporate maps into your products so your users can have the best experience possible. Now, before I get into the meat of the talk, I do want to do a little slight recap and go over the last 12 months. So last year, at I/O, we announced the Google Maps platform, and we committed to evolving our Maps APIs into a more simplified, more scalable, easy-to-use set of tools that meet your needs. Now, it's been a very busy year, and we know that a couple of these changes weren't easy to adapt to. Some of you had to adapt to new prices. Others had to make changes to your code bases based on changes that we made to our APIs and SDKs. But I want to reassure you that we've been hard at work for you to improve the developer environment for you. And I just want to give you a little taste on what's happened underneath the hood. So for the past year, we've really focused on the stability, the reliability, and the performance of our platform so that we can guarantee our 99.9% uptime for our SLA. This helps us continue to provide over 150 million places for you and your users. It continues to allow us to have routes that cover more than 40 million miles on the Earth, and it allows us to serve you maps that cover 99% of the world. Some changes that you might have felt more directly, we now offer support available to everyone, not just a subset of developers. We've upgraded our Places SDK on Android and iOS, and we continue to invest in some of our industry solutions. In particular, we have some meaningful partnerships that we've established in the gaming community and the ride-sharing community, and great things are being worked on as we speak. But on to what we'll be covering in this talk. So we're going to go through a number of things. I'll try not to go through it fast, so please forgive me if I'm a little speedy on this. But first, we're going to dive into performance. Then after we go into performance, we're going to talk a little bit about data visualization and WebGL. And then we'll end it off talking about building faster on the Android platform. So performance at scale. This section of the talk, for everyone in the room, I'm going to focus on the web and mobile web platforms. The reason for this is because the majority of feedback that we've received from developers who've experienced performance issues when rendering a lot of data on top of our maps, they come from the web community, so mobile and web developers. And note that the things that I'm going to suggest on stage can be applicable whether or not you are a mobile web developer or a desktop web developer or both. So one of the main abstractions that developers use to render a lot of content on the map are custom overlays. So I don't know if you're familiar with custom overlays. Some in the room might not. Some on live stream or YouTube may not be. But custom overlays are merely a layer of geospatial data that you render on top of the map. So imagine yourself being the owner of a real estate site. You could render all the listings and the property bounds using the custom overlay. So what does that look like? Well, first off, your custom overlay needs to extend our overlay view. You'll have a constructor. It may or may not take a map. More than likely it will, though. There are a couple of lifecycle methods that you need to implement. So there's an on-add method that you implement when the map is actually ready to use your custom overlay. And when the map decides to remove the overlay, there's an on-remove method to help you clean up the state that you've accumulated during the time it's been in session. But the interesting method here is a draw method. And the reason why this is interesting is because This method is called every single time that we draw the map. So developers should take great care in determining how much work and what type of work you do within this method. So I'm going to talk a little bit, give you a few suggestions on just on consultation that we've provided to developers over the years to allow you to avoid some of the pitfalls we've seen from previous developers. So the first item up here, do not add or remove content until the user stops moving the map. Just to kind of reiterate this a bit, the map experience, we redraw that every time the user moves the map. So if a user is dragging, we are constantly trying to redraw that scene. And if your custom overlays are taking a while to actually complete, that could introduce some stuttering or a little bit of lag or jank into the overall map experience. So if you look at this example here, this is an example of us adding content and removing content on the draw method, regardless of whether or not the map is moving or stopped moving. As you can see, as you move over, as the user pans the map, the right side of the map takes a while to load. It feels a little janky. And the reason that's happening is because we are adding and removing content while we're actually drawing the map. In contrast, here's an example where we only add and remove content when the map is stabilized. You can see as we pan, the map renders more smoothly, and when the map becomes stationary, new content is shown displayed on top. This leaves for a better user experience for your end users. But this type of problem points to a larger issue, and the main takeaway here is do not perform heavyweight non-drawing logic in your draw method, just period. So when your users are looking at the map, they think of the entire map experience. And if we want to provide a very performant solution, we only have a certain amount of time to render each and every frame to guarantee the frame rate that we want to show. So in this graph here, this middle line represents 16 milliseconds and 16 2/3 milliseconds, which equates to 60 frames per second. The rightmost line equates to 33 1/3 milliseconds, which equates to 30 frames per second. And if we take longer than this to render a frame, we're probably going to introduce some jank to the user. They'll notice, and they'll frown, and they'll cry. I'm sorry. So in general, we do a fairly decent job for our users, just the base map itself. On average, strike that. Our median draw time for rendering a frame is between 16 to 18 milliseconds. Some users, for various reasons, experience worse performance than that, so it might take a little longer to draw a frame. It could be due to hardware, browser version, a number of items that factor in here. Some users have a much better experience than our median results. But regardless of whether or not you have a user that has a great base map experience or one that doesn't have the optimal base map experience, we should provide them with an overall smooth and interactive map. And it's not just us that provides that to them, but it's also you all in the custom overlays that you add onto the map. So in your draw method, if that takes 1 to 2 milliseconds, you're pretty much guaranteed to have a very performant experience regardless of whether or not your user is on a high-end device or if they have the less optimal maps, base map experience. They still have a fairly decent overall experience. However, if you are querying for a lot of content, making a lot of changes to the data that you're showing within the draw method, if you're also possibly manipulating a lot of DOM elements during this draw call, you could introduce a lot of time in your draw method. And although you may have some users that are on a very high-end device that you might have a performant experience on, there will inevitably be users that don't have that same experience and experience jank. So please like help us. Together we can provide a more useful experience for your end users. But as we've talked to people, talked to developers, and got a general sense on how people use custom overlays, we started to find that our markers API could solve a lot of the use cases that we saw. And this also has the added benefit that you as a developer don't have to worry about making a performant implementation on rendering a lot of content on the map. That responsibility can be placed on us and free you up to do other things. But a lot of developers aren't aware of different marker performance characteristics. So we're going to walk through an example where I add 1,000 markers on the map, and I can show you how small changes can lead to some large performance implications. So we'll start with a little bit of code. This is just a method that takes a lat-long bounds and a number of points and creates that many number of random lat-long locations within that lat-long bounds. I use this to make 1,000 points. In this demo I'm about to show, I initialize a map. I create a marker for all 1,000 of those locations. And I use the SVG asset for the icon because everyone loves SVGs. And I also add mouse over and mouse out listeners to toggle the icon as the user pans over the map. So here's an example. Here's that example. These markers are over Australia. And I will note that I'm actually trying to zoom into the map. And there's just a large lag in the experience. So I'm panning around, just showing that there's actually a couple of second delay between my user action and the drawing of the results on the map. All right, this is kind of making me cringe a little bit. So you're probably saying, what gives, Travis? You told me that you're going to show me an example where you render 1,000 markers on the map, and it was a great experience. Doesn't seem like you added a lot of code. What gives? So there's one line in this that I want you all to look at. It's this lovely SVG asset. I'm just going to make one change. We're going to change this to a PNG, and we're going to rerun this demo. So now, if you run this demo, you have a much more performant map. It follows my user gestures pretty well, and the performance characteristics of this demo completely changes. And the reason behind this is, for right now, please use JPEG or PNG assets. If you are using SVGs, try to rasterize them first. It's just more effective and more efficient in general to render a raster image for the user, use a raster image for the icon as opposed to a SVG representation. But as an aside, while I'm talking about raster and vector, when I took this job, one of the product managers in the organization told me that there are some developers that innately feel that because we offer a raster-based maps experience through our APIs, that somehow that means that it's inherently less performant than if we went with a vector graphics solution, maybe like a WebGL offering. So I wanted to put a little data to that. So if you look at one of our raster-based products that we offer, which is a progressive web app version of Maps, is a raster-based experience that we, the Google Maps platform, power. And the median FPS across live traffic that we've analyzed for a while through various actions is around 55 milliseconds. Contrast that to if you go to maps.google.com on a device that supports WebGL, you get a complete WebGL powered experience, but the median frame rate for that experience is around 51 frames per second. So this is not to champion or knock either platform. We provide both options within Google, but we save the WebGL for the consumer experience. But this just serves that whether we serve you a raster-based implementation or a vector-based implementation, you will have a performant base map to build your web applications around. So back to our example. If you look at this map, I don't know about you, but if you want your users to interact with the individual contents that you add on top of the map, it's hard for me to decipher any meaning on the content that we're adding, because there's 1,000 markers on Australia. I can't even see the majority of Australia. So one last note, don't forget to cluster. We have a marker clusterer support library that we offer. And in my demo example here, I use that in order to cluster content on the map again. So there are a couple of options that you can use. There's a grid option size, which controls the amount of markers that we cluster together into one group. There's a maximum zoom, which controls the maximum zoom level after which you shouldn't see clusters. And then you can provide an image path that has the base URL for the cluster icon assets. Note, those should probably be PNGs and JPEGs as well. With that, you can just instantiate a marker clusterer, given the map, the markers, and these options. And you get an example just like this. So already, I'm able to see where a lot of the action is in Australia, and if I want, I can choose to tunnel down in different spaces. But in this demo, I'm just moving the map around violently just to show that the map is interactive, even with this additional clustering logic on top. So if you want to know more about Maps clusterers, you can go to this short link. There's one thing that you should note. We have changed these short links. We now have the E after the goo.gl. So now it's the full kind of Google with a dot in the middle. So take that as a note. And just to recap, we've talked about custom overlays. You want to add and remove content when the map isn't moving. You don't want to have heavyweight operations in your draw methods. For markers, you want to consider using markers instead of custom overlays if possible. Use JPEG and PNG assets as opposed to SVGs, and don't forget to cluster. But we've kind of talked about what you can do now, but I'm sure there's a few of you there wondering, what's next? Especially if you are a developer that has a lot of data that you want to show. You're probably saying, Travis, it's very nice and fun that you showed an example where you are rendering 1,000 markers on the map, but I have to be honest with you, I have hundreds of thousands of data that I want to see on the map. I might have millions of things I want to show on the map. What do you have for me? So I'd like to announce that we officially have a partnership with the great folk over at DecGL. For those that do not know what DecGL is, it is an open source data visualization library. It uses WebGL on client side to render huge amounts of data sets overlaid on top of a base map. That base map could be your Google map. So DecGL has a number of layer examples that you can read up more on. But this example here is an arc layer where there are arcs connecting a start point and an end point, and the arc is a 3D arc that actually goes into the screen. So in this example, this is an arc layer over around 16,000 New York City cab pickups. I'll just zoom in just so you can see that there are a bunch of lines in this example. We probably would have a better visualization experience if we offer tilt. Sad to say, Google Maps on the JavaScript platform does not support tilt, at least not yet. I like flights, so I have another flight example. This is an example of animating the flight paths around London. So this starts to show you a little bit of the power that you have when you pair DecGL with the Google Maps, whether or not you want a static dynamic visualization experience or you want more of a dynamic animated data visualization experience. This DecGL and Google Maps partnership is a stepping stone to get you where you want to be. So how does this look in code? This is very similar to a standard example of just incorporating a map. You have a div for your map. I'm including the latest DecGL JavaScript binary. You also have a canvas for the DecGL experience that'll be overlaid on top of the map. I have some constants here that just define different camera properties. In this example, the pitch is set to 0. That's because Google Maps does not support tilt yet. Once again, at least not yet. One of the challenges that DecGL and Google Maps had to overcome in making this partnership work is reconciling between two different camera models. Now, we will continue to work on this as time progresses, but for the short term, you need to apply a zoom level offset for the Google Map camera, and that's actually just one. On this example, I'm also supplying just a sample type of URL to some Geo JSON data. I'll talk about what Geo JSON is a bit later. And from that, you can initialize a map, very similar to what you already do. You apply the camera zoom offset for your Google Map. You create a new DecGL experience with the Dec canvas. You pass in that same view state minus the camera zoom offset. In this example, I'm disabling rotation. DecGL DecGL supports camera rotation. Google Maps does not, at least not yet. And there's a callback for when the DecGL view state changes. And essentially, it just tells the map to follow suit. In addition to this, you can supply a number of DecGL layers to overlay on the canvas. And this one is a Geo JSON layer. And for those that aren't familiar with Geo JSON, it is a geospatial data format akin to KML. For those in the GIS community that know of KML, you can incorporate points and lines and polygonal geometry to render on top of the map. So with this Geo JSON layer and DecGL, you can supply the URL to wherever your Geo JSON file is, and there are various parameters that you can use to customize the experience. But I'll show you documentation. I'll show you a link to documentation on where you can dive deeper into that. But right now, I want to switch to a live demo. So in this demo, this is showing earthquake data in the West Coast. And you're probably saying, Travis, there's not a lot of earthquakes. But as you zoom out, you start to see that we have tens of thousands of, sorry, I actually clicked on one of the hurricanes here, but we have tens of thousands of points. And this is actually being rendered interactively on client side using WebGL. This demo, just want to give a shout out to the great people over at Ubi Labs. They're the ones that created this demo. So thank you to them. And with that, I'll just go back and transition back to the slides. So here is a short link that can give you insight on how to incorporate DecGL and Google Maps into your web applications. Remember, we added that seed to this link. But this partnership was the beginning of bringing WebGL to the Google Maps API. But in all honesty, we really need your help here because we want to continue our investment in WebGL. We want to offer more to you as developers. So we want to call for your ideas. I really want to know how you feel WebGL can enable new types of features that your users can benefit from. So whether or not you're like looking at maps.google.com and you zoomed out and you see the spherical globe, or if you're looking at the 3D imagery within maps.google.com, or if you're using maps, zooming in, going into 3D imagery, and then transitioning into Street View. Just really want you to think outside the box, think outside of the confines that we've had up to this point, and really think about ways that WebGL can empower your users. So I'm going to pause a little bit on this slide because this is the action item that I really want the developers in this room and those on live stream and YouTube to take. I really want you to go to this website. This will be live for about a month. This will link you to a form where you can start to tell us some of the ideas you have on how we can actually better use WebGL in our API offerings to you, and what types of things or classes or features you would use them for. So please join us and go on this link and provide us a little insight on how you think we should bring WebGL to the future. So we talked about the web for a while. I want to transition over to Android for a sec. Congratulations. You, as of right now, are my beta testers for the new Android Maps SDK. Yay, congratulations, thank you very much. But this SDK is a little different from how we've historically delivered SDKs to you. So there is an action item here. We are moving our SDK out of Google Mobile Services, and this will be a library that you need to statically compile into your apps. So there is an action associated with adopting and trying out this beta. But we've done it for a few reasons. So, little known fact, the Google Maps mobile app and the Android Maps SDK that we offer in our platform before now have been built on completely different map stacks. And this new SDK, we're actually rectifying that. And so now, the Android Maps SDK and the Google Maps mobile app are both built on the same map stack. So this gives us our path for delivering more of the goodness out of the Google Maps mobile app and offering that to you as developers. I mentioned this when I said we were removing our SDK out of Google Mobile Services, but a reasoning behind that is to allow us to have more frequent version releases to you. So our future releases, where we invest and add new features, it will be outside of Google Mobile Services, and it will be a static SDK that you need to compile into your app. But a benefit to you in this process, outside of us having more frequent releases to you, is that now you can test out the latest version of the Android Maps SDK without pushing it out to your full end user base. We also are thinking a little bit about your users on this. So we want to save them money when they're not on Wi-Fi. So the map data that's used to render the maps with this SDK uses up to 60% less data. And because we went through the process of refactoring a lot of our SDK so that we were built on the same stack that the Google Maps mobile app is built on, in that process, we closed 65 external issues. You can look at the issue tracker and see which issues were handled. So I'm gonna pause again. Here's a link to a migration guide. We need your help. We need your help here. I'll repeat, we need your help here. We want you to go to this site, read up on the migration docs, and actually test out this SDK within your products. If you see bugs, let us know so we can fix them quickly. But please, once again, go to this migration guide, read up on how to incorporate the new Maps SDK into your Android apps, and let us know how it goes. So we've circled through a number of different things, but I want to talk about the future. So in the past, we focused on building and will continue to grow various industries, from the ride-sharing industry to travel to real estate and more. But now we need to focus on the industries that you want to build. So let's build those industries together. And you can start this week by meeting us. You can start this week by meeting us for our office hours tomorrow at 11:30 a.m. and on Thursday at 12:30 p.m. And you can also catch us in the sandbox with our cloud partners in the Cloud Dome. So with that, I'd like to thank you for your time. For those in the audience, thank you for your time. Those in live stream and those watching on YouTube, I appreciate every moment of it. Take care.